We physicists have held up a 100 years starting around 1916 for this photo. It is an area. Dark openings may very well be one of the most interesting and secretive peculiarities in the universe. They are monstrous monsters with regards to control, yet at a similar time basically undetectable to us. A dark opening weighing maybe 2 to 4 multiple times the mass of the Sun. Yet, in light of the examination that was put into them over the last several many years, we've gone from knowing literally nothing about them to getting to find out increasingly more very close and individual, and things have recently gotten more insane. Michio Kaku recently reported that we at long last got a gander at what's inside a dark opening, and this new data carries light to the subtleties the universe of science could have missed from the start. Join us as we dig further into dark openings and uncover what's inside. Space is large, terrible. What are dark openings? Before we get into the subtleties of what Michio Kaku found, we have to discuss the main. Despite the fact that most of us have some thought what dark openings are, there are still a few holes in the right data. You see, in 1916, Albert Einstein distributed his hypothesis of general relativity, which anticipated the presence of dark openings. Around then, the idea of dark openings was simply hypothetical. It required an additional 50 years for the logical local area to track down proof that dark openings really exist. This occurred in the 1960s. They were contemplating the Cygni X1 heavenly body when they saw a strangely dazzling blue star that was discharging X-beams. This star was certainly not a stale object, yet was circumventing a monster dark something. Upon further examination, it was seen that as the X-beams weren't simply moving around on their own, yet they were being sucked into the dark thing they were circling. Consequently, the name dark opening. This disclosure was critical in light of the fact that it gave confirmation that dark openings really exist and that they weren't simply a fabrication of Albert Einstein's wild creative mind. While that was extraordinary, it additionally intended that there was this stunning substance in space that we desperately had to find out about. So, analysts from one side of the planet to the other got to work. This dark opening was named Cygnus X1, and it is situated in the star grouping Cygnus around 6,000 light a long time from Earth. And it was no little disclosure. It's multiple times more brilliant than the Sun and unbelievably thick, which makes it have a solid gravitational force. The gravitational draw is such that not even light can get away from it. To this end, it is known as a dark opening. The idea of a dark opening is both intriguing and startling. It is a region of room where gravity is solid to such an extent that nothing, not even light, can avoid. Whatever gets excessively near a dark opening will be pulled into it, gone forever. However, that part of risk makes it significantly more important to learn all that there is to realize about them. Was this it, or were we simply starting? The response wound up being the last option. After the revelation of SSX1, researchers began to look for other dark openings. They tracked down that there might be near more than 100 million dark openings in the smooth manner alone. But since they are so inconceivably difficult to distinguish, we still don't have an exact number. By and by, from the vibes of it, there are a few million dark openings in the smooth way in our very world, which is what makes them much more essential to concentrate. So how about we separate it? The fundamental worry with dark openings is continuously going to be gravity. Their gravitational force is serious to such an extent that anything that enters it packs down cosmically until it turns into a peculiarity. In less complex terms, dark openings resemble inestimable vacuum cleaners that suck everything in. One of the most frightening parts about the exploration that has gone into dark openings is the reality that if somebody somehow happened to fall into one, they would quit wasting time. That they become a solitary line. This cycle would happen gradually, and the individual would pass on before the last structure indeed sets in. So, let's just say that nobody ought to step into one except if they're everywhere. So might we at any point truly be in peril? In spite of the way that the nearest dark opening to Earth is when 500 light-years away, it's actually adequately close to raise various forms of feedback. And in 2021, researchers had the option to deliver the first clear photo of a dark opening, explicitly the M87 dark opening. This dark opening was captured a few evenings in succession, and with each photo, the scientists assembled to an ever-increasing extent proof about it. They needed to fasten the individual photographs together to make something that filled every one of the holes. This way, they had the option to sort out that there are 3 layers to a dark opening. It's not only one single expanding opening of nothingness as many individuals accept. Things are significantly more muddled than that. To try and get to the nothingness part of a dark opening, you need to make it through the initial 2 layers. The first layer is known as the occasion skyline, which, while in the main layer, is the place of no return. Once you pass the occasion skyline, there's no way other than straight ahead, and you will be sucked into the dark opening. Yet, the 3 layers just deteriorate from there on out. The subsequent layer is the photon circle, which is the district where light circles the dark opening. Any light that enters this area will be caught and cannot get away from the dark opening's gravitational draw. Finally, we come to the 3rd layer, which is the peculiarity. This is where all that enters the dark opening gets packed out cosmically until it turns into a peculiarity. The peculiarity is a point in spacetime where the regulations of material science, as we probably are aware, them separate, and we can't foresee what occurs next. Now, what makes all of this endlessly more terrible is the way that each and every dark opening you study will be totally not the same as the last. Certain, they, in all actuality, will quite often follow something similar 3-layer idea, however, the way they capability could be boundlessly unique. At this point, assuming that this were anything more, all we want to do is bounce back on those telescopes and simply concentrate on the main issue in detail. But with dark openings, you can't truly do that. Researchers can study dark openings by implication by noticing the radiation they emanate and the gas and residue that encompasses them. Sending a test like the Explorer inside a dark opening isn't conceivable on the grounds that anything that enters the occasion skyline is pulled towards the peculiarity where it is packed to an endlessly little point. So, you can't precisely squander billions of dollars just to get an impression each time, because the second the test draws near enough, it'll simply squash into nothingness. As a result of that amazingly obvious issue, researchers are left with no choice except for to study these objects in a 2-layered manner, even however they are 3-layered peculiarities. In all actuality, to make matters considerably seriously testing, there are additionally the 2 issues of each and every dark opening being novel and the laws of physical science as we realize them separating when we attempt to investigate within the development of dark openings. Conventional techniques for logical request don't actually apply to the investigation of dark openings. That doesn't imply that the analysts haven't been occupied. There are loads of various speculations and clarifications of dark openings, and well, with everyone, things get more and seriously fascinating. One of the most convincing hypotheses about the development of dark openings is that they are made from imploded stars. All at the point when a star depletes its fuel, it can no longer create sufficient energy to check the power of gravity that is continually pulling internal. So, the star starts to implode in on itself, reducing and denser as it does so. Assuming the star is gigantic enough, this interaction can go on until it turns into a peculiarity. To comprehend the idea of dark openings top to bottom, NASA researchers directed their concentration toward the center of the cosmic system. M87 stargazers noticed a strong whirlpool of very hot hydrogen gas that was turning at an amazing pace of 1.2 million miles each hour. The sheer power of the turning circle of gas ought to have made it viciously fly separated every which way, yet it didn't. Researchers concluded that there must be a giant mass amassed at the focal point of the system to keep this from happening. This gigantic item weighed as much as 2 to 3 billion suns and must be a dark opening. But that's by all accounts not the only hypothesis. In 1963, the New Zealand mathematician Roy Kerr utilized Einstein's conditions of gravity to give the best portrayal of a turning dark opening. Kerr showed that a turning dark opening wouldn't fall into a point as previously suspected, but to a ring of fire or a flimsy plate. The plate would turn so quickly that centrifugal forces would keep it from falling. This turning circle of issue is known as the ergosphere, and it is the region encompassing the dark opening where the laws of physical science begin to separate. However, the most fascinating component of Kerr's arrangement was that it anticipated the presence of an Einstein-Rosen scaffold, otherwise called a wormhole. This is a hypothetical section through spacetime that associates 2 separate regions of the universe or even 2 equal universes. The thought is that assuming one were to fall into a dark opening, rather than being squashed to insensibility, one would be sucked down a passage through the ring of discharge and shot out a white opening in a parallel universe. To grasp how this works, we really want to take a gander at the idea of spacetime in Einstein's hypothesis. Existence is not discrete entities but are interconnected, forming a 4-layered texture called spacetime. Objects with mass twist this texture, making a gravitational field that makes different particles move towards them. Presently, envision a piece of paper addressing spacetime. On the off chance that you place two focuses on the paper and define a boundary between them, this is a portrayal of how particles travel through spacetime. Yet, imagine a scenario in which you could crease the paper down the middle and make an easy route between the two focuses. This is the fundamental thought behind a wormhole. It's an easy route through spacetime that associates two far-off focuses in a moment. Wormholes aren't simply a science fiction idea. They are, as a matter of fact, an expectation of general relativity, albeit nobody has at any point noticed one straightforwardly. The explanation is that wormholes are intrinsically unsound and would break down very quickly. Yet, the presence of an Einstein-Rosen extension would imply that dark openings are not simply vast vacuum cleaners but could also be pathways to different areas of spacetime. So might we at any point utilize a wormhole to travel through reality? Tragically, the answer is most likely no, not yet. Regardless of whether we could settle a wormhole, it's far-fetched that we could utilize it to travel quicker than light. Einstein's hypothesis of exceptional relativity predicts that the speed of light is an outright limit on how quick anything can travel through spacetime. Yet, and after it's all said and done, the hypothesis of wormholes and dark openings as pathways to different pieces of the universe, or on the other hand, even to various times, has been a subject of interest and theory among physicists for a really long time. The thought that there may be easy routes through the texture of spacetime permitting travel through huge spans or even into the past might actually be progressive if we could really accomplish it. The Mutt wormhole, one of the most charming ideas around here of study, is the CR wormhole, which is named after the mathematician Royer, who originally depicted Einstein's conditions of gravity. This sort of wormhole is basically a speculative cylinder through spacetime that could interface two far-off focuses, for example, two unique universes or even two various times inside a similar universe. The dog wormhole is ring-formed comparable to the mirror in the narrative of Alice into Another World, and might actually move an explorer to another universe or some other time where the laws of material science may be very not quite the same as those we are familiar with. However, at the objective, that could simply be ordinary. While the possibility of wormholes for interstellar travel or time travel is unquestionably invigorating, as we've overlooked previously, it's also a subject of contention and banter among physicists. Some have called attention to that wormholes, and particularly dog wormholes, may be unsteady or difficult to navigate due to the extraordinary radiation and subatomic powers encompassing their entry. The pundits contend that Einstein's conditions of gravity, which are utilized to depict wormholes and dark openings, just work for gravity, and that's what not the quantum powers oversee radiation and subatomic particles. To comprehend the nature really of these peculiarities, another hypothesis is required that can join the laws of gravity with the quantum hypothesis of radiation. All through the universe of science, this is known as a hypothesis of everything, a solitary hypothesis that can join both Einstein's hypothesis of gravity and the quantum hypothesis. Kaku, who's a famous hypothetical physicist, has been dealing with a hypothesis of everything for many years as well. While there are loads of various adaptations of what this could be, the one that has shown guarantee is superstring hypothesis. Superstring hypothesis joins gravity with the hypothesis of radiation. The hypothesis recommends that subatomic particles are really little vibrating strings, and that the universe is an orchestra of these strings, similarly as different melodic notes relate to various vibrations of a violin string. Various particles in nature compare to various vibrations of a superstring. One of the intriguing things about superstring hypothesis is that as a string moves in time, it twists the texture of space around it, creating dark openings, wormholes, and other fascinating arrangements of Einstein's conditions. This implies that superstring hypothesis not just joins together Einstein's hypothesis of gravity with the quantum hypothesis, but it additionally makes sense of quite a large number of the baffling peculiarities that we see in the universe. Yet there is a catch. The additional elements of spacetime that superstring hypothesis requires are so little that we can't actually concentrate on them straightforwardly. The most exact estimations that we can make in our research facilities just utilize the four elements of spacetime that we know all about: length, width, profundity, and time. So how might we even know that the additional aspects exist? One chance is that the extra aspects are nestled into firmly that they are imperceptible to us. Envision a sheet of paper that has been firmly moved up into a chamber. In the event that you were an insect strolling along the outer layer of the paper, you probably won't actually see that the paper is bended. Likewise, the additional aspects of spacetime in superstring hypothesis could be nestled into little circles or twistings that are imperceptible to us even however they influence the way of behaving of the strings that vibrate in them. Another probability is that the additional aspects were more noticeable toward the start of the universe, during the enormous detonation. As per certain forms of superstring hypothesis, the universe started in a condition of 10-layered spacetime, with every one of the aspects similarly noticeable. As the universe extended and cooled, the additional aspects started to fall and twist up, leaving us with the 4 aspects that we notice today. If the situation is right, then we may be ready to distinguish hints of the extra aspects around us. The math engaged with superstring hypothesis is incredibly perplexing. It has opened up totally new areas of science that were beforehand neglected. However, the challenge of tackling the issue of a quantum dark opening has shown to be a subtle one. While numerous physicists have attempted to handle this issue, nobody has however had the option to do so. Edward Witten of the Establishment for Cutting-Edge Learn at Princeton has called superstring hypothesis 21st century material science that fell unintentionally into the 20th century. Last year, a few gatherings of physicists freely declared a critical advancement. They tracked down that string hypothesis could totally address the issue of a quantum dark opening, although just in 2 aspects, not 10. Numerous physicists accept that it's just a matter of time before somebody breaks this issue, given that the conditions involved are distinct if difficult to address. Up to that point, it's still too soon to purchase tickets for intergalactic travel or time-traveling campaigns. In any case, with regards to dark openings, with all of this, one thing is clear. There are essentially such a large number of inquiries and, surprisingly, more answers for these issues. Kaku's string hypothesis puts one more twist on it all. Perhaps the enormous detonation wasn't exactly all that large after all. He says it was anything but a gigantic blast, as many would naturally suspect. It likewise didn't make a noisy commotion like one could anticipate from a bang. The huge explosion hypothesis doesn't give a clarification for what caused the alleged bang or how it happened. It just expresses that it did happen. Truly, we want a hypothesis that can represent what occurred before the enormous detonation. This is where string hypothesis comes in. As per this hypothesis, our universe could have been framed from the crash of 2 separate universes, or then again it might have risen up out of another universe like a child being brought into the world from its mother. This association between universes is known as a wormhole, which is like a tube interfacing 2 air pockets. It's conceivable that we might have as of now found proof of this umbilical rope that associated our universe to one more. In a manner, we could simply be living inside a dark opening this entire time.